So this video is for the first section in Chapter 2, Section 2.1, which is about representing intervals. So if this is easy for you, that's wonderful. I've found that people do occasionally struggle with representing intervals. So first of all, let's look at something very simple. Let's say this one. Okay. So this is where the 5 is colored in, and then we've shaded all the numbers that are greater than 5. And this is an arrow right here indicating that this goes on to infinity. So we want to use the greater than or less than symbols. So, and also less than or equal to, greater than or equal to. So the first thing that we have to do is to understand the difference between the less than symbols and the greater than symbols. Okay. There's a couple different ways that you can remember this. If you have a method that works for you to help you remember, that's wonderful. What I always remember is that the symbol will always point at whatever's smaller, right? See, if you're using the less than symbol, then it's pointing, let's say, x is less than 2. Okay? It's pointing at the thing that's smaller. If you want to use the greater than symbol, x is greater than 10, notice it's still pointing at the thing that is smaller. So that's always helped me to remember how this works. The other thing you can look at is that the wide opening faces the larger quantity, the small opening or the closed space faces the smaller quantity. Okay, and that's true here as well. The x is bigger, the 10 is smaller. So over here, we want to say x is greater than or equal to 5 because the 5 is included. So we're going to be using one of these symbols. So we could say x is greater than or equal to 5. You could also do it this way. You can still say x is greater than or equal to 5. You can say 5 is less than or equal to x. Either way, so long as it's pointing in the right direction. Okay? Notice that all these x's out here are bigger than 5. That's why this is pointing at the 5, because it's the smaller quantity. Okay, so that's the basic idea of the greater than and less than symbols. Let's see here. So let's look at some of the problems in the textbook. These are on page 85. We'll start with problem 2. And so I'll make a little drawing for this one. Let's see here. Problem 2, we've got -5 out here and -1 over here. Right, and then we've also got +8 and +12 included. Okay, so we have 2 intervals to represent, so we're going to need 2 separate statements to represent them. So the first statement that we want here is to say that x should be less than the -1, but greater than or equal to the -5. Okay, and again, you can turn these around if you'd like, so long as they're pointing in the right direction. So these are both correct. Okay, let's see. Over here, we would have x less than 12, x greater than 8, and again, you can turn this around if you'd like. Okay. Now, when I'm hand grading, I'm pretty understanding if you leave out the or in between these statements. But when you're doing the online quiz, the software will have these symbols available to you as you're taking the quiz. There'll also be a choice for or. Okay, so that's how you should get used to answering these. Use these symbols to create one of these intervals, and then to separate it from another interval, you want to use the or statement. Okay? All right, so that's problem 2. Let's see here. Let's look at problem 6. Problem 6 looks like this. Let's see, we go from -2 up to +7, and these are both included along with all the numbers in between them. And then we've also got -5 out here, and then everything going out in that direction to -infinity. Okay, so we have two separate intervals here. We'll need two separate statements to represent them. First off, we want to say x is less than -5, and then we'll put or, and then we want x greater than -2, but at the same time less than or equal to 7. Okay, so we've got two intervals and two statements to represent them. Let's see here. Oh, let's go back and take a look at number 4 before we move on here. And I talk about problems like this in the write-up for this section 2.1, which I encourage you to read on pages 83 and 84. It's very short, but I think it's a good review of these concepts. Okay, so in problem 4, let's see, we've got -4 here, and then going off to -infinity, and then +6 here, and then going off to +infinity. Okay, so we have two separate intervals here, so we need two separate statements to represent them. This one is x less than -4, and then we put or, and then over here x greater than +6. Now, in those other problems where we had an interval, a two-sided interval, whether or not they were colored in, let's say this was 10 and this one was 17, we would say x less than 17 greater than or equal to 10. So we have a single statement to represent this single interval. Here we have two separate intervals, so we need two separate statements to represent them. Sometimes people try to put these together and they say, well, let's see, the x is greater than 6 and the x is less than -4, so why can't I do this? Well, what's happening here is that if you write it like this all together, what you're saying is that these are both true at the same time. X is both greater than 6 and less than -4 at the same time. That can't happen. Okay, that's why we have the or statement. X can be greater than 6 or it can be less than -4. It can't be both at the same time. If you look at this example right here, right, you can see all these numbers between 10 and 17, they are both less than 17 and greater than 10 at the same time. So that's why you can use a single statement to represent this single interval. If you've got two separate intervals, you need two separate statements to represent them. Please don't put this on your answers. The computer will mark it wrong. I will mark it wrong. Just, if you've got separate intervals, you'll need separate statements. Okay, let's see here. Let's move on. Let's take a look at problem 8 over on page 86. Let's see what we've got. So in this one, we've got a 15 out here, and then in here between -2 and +2, and those are both included there. And then the last one is out here at -6 with an open circle going out to -infinity. Okay, so in this one we have 1, 2, 3 separate intervals. We'll need 3 separate statements to represent them. We'll start over here. This one says x less than -6. Then we'll put or, and then we'll put x greater than or equal to -2, but less than or equal to +2. And then we'll do or one more time and say x greater than or equal to 15. So we've got 3 intervals. We've got the 3 separate statements separated by the word or to represent them. All right, let's see here. Now let's take a look at a couple that are a little bit trickier. Problems 10 and 12 have these issues that we haven't seen yet in these problems. So let's talk about them. Let's see. In problem 10, we've got this interval from -2 out to -6. And then we've just got this dot out over at +3. So if you have something like this, we've got this interval here. We can represent it x less than -2, but greater than -6. Or this is just 3. So we could just say x equals 3. Okay? And this happens sometimes in the problems that we're going to be using this for. These situations do sometimes come up. Okay, so that's problem 10. Let's see here. Problem 12 is, well, let me just draw it. Problem 12 basically looks like this, with arrows on both ends. So, this is all real numbers. Okay? And so, if you ever had an answer for that, or if you ever had a question where you needed to indicate all of the number line, the entire number line, you can write all real numbers. Okay? The mathematical symbol to represent that looks like this. You don't have to worry about that, but this just says x is a member of the set of real numbers. Mathematicians use that double-barred R to represent the set of real numbers. Okay. All right, so that's it for section 2.1. It's a very brief section, and in fact, the quiz for this will be combined with the quiz for section 2.2, which I'll talk about in a separate video.